This is part 5 of the Module 8 lecture. And here we're going to review more examples. In example 2, we have a customer of a software company claims that their call center takes on average 15 minutes more to resolve common issues. The software company says that they have implemented several improvements and they believe that the response time on average is now less than 15 minutes. So the manager of the call center wants to validate that these improvements have indeed resulted in a time to resolve issues of less than 15 minutes. And so he collects a sample of 50 response times and calculates the sample mean, which is 14.8 minutes, and the standard deviation of the sample is 5.2 minutes, respectively. So the question is did the improvements that the company implemented work? And we're going to use a significance level of 0.1. All right, again, I underline some key things like average, so that it clues you into that we're dealing with a continuous random variable, and of course it's time, so that's a continuous random variable, or the response time specifically here, and we're dealing with the average. Now, if you notice, the customer says 15 minutes or more, and then the manager of the company claims less than 15 minutes. So here is your null hypothesis, and here's your alternative hypothesis. All right, so let's summarize the information. So the mean under the null hypothesis is 15 minutes, the sample size is 50, the sample average is 14.8 minutes, and the standard deviation is 5.2 minutes, and the significance level that we want to use is 0.1. All right, so now using the description of the null hypothesis and that of the alternative hypothesis, then we can write that the null hypothesis is that the mean is 15 minutes or more, and the alternative hypothesis is that the mean is 15 minutes or less. Now, from the alternative hypothesis, you can see that this is a left tail test. We're looking for values of the mean less than 15 minutes, and the significance level is 0.1. All right, so what distribution to use? Here they don't tell us anything about how they obtain the sample. So because we don't know anything beyond that, here we're going to assume that these observations are independent. The sample size is 50, so we can rely on the central limit theorem to say that the sampling distribution of the mean is normal. Then the population standard deviation is not known, and we're going to replace it with the sample standard deviation that we know from the sample. And so we're going to use a t-distribution with 49 degrees of freedom, so 50 minus 1. All right, so we calculate the test statistic. We know the sample mean, we know the value under the null hypothesis, we know the sample standard deviation, and we know the number of observations in the sample. So the calculated value of the test statistics is minus 0.272. All right, so let's look at how we find the critical region using the critical value approach. All right, so we're going to use an alpha 0.1 with degrees of freedom of 49. And if you go into table 5, you find that the t-value is 1.299. But this is the value on the right side of the distribution because it's giving you values for larger than the t-value. But we can use the symmetry of the t-distribution, and since it is centered on 0, we can say then that the critical value is just a negative value of the equivalent value on the right side of the distribution. So the t-critical in this case is minus 1.299. And the rejection region is to the left of minus 1.299. Again, if you want to find the t-critical using Excel, here is the formula. All right. Now, for the p-value approach, so again on table 5, we look at the row of degrees of freedom of 49, and we can see that the value minus 0.272 is larger than the larger value on that row of 49 degrees of freedom of minus 1.299 that corresponds to probability of 0.1. Again, I'm using the negative values because I'm looking on the left side of the distribution. And remember, what the table shows you is the probability, or rather the t-values on the right side. by symmetry, you can look at them on the left side and just put the negative value. All right, so that we see that the p-value is going to be larger than 0.1 because 0.0272 is larger than, minus 0.272 negative is larger than negative 1.299. And you can see that because this minus 2.72 is closer than 0 than this value. Right, if you want to find the exact p-value, here's the formula, and you find it that it is to be 0.06066. All right, so now with that information, we can look at the critical approach, the critical value approach, and you find that the observed or the calculated value of the test statistic is larger than the critical value. That means that this value lands in the non-rejection region, and therefore we reject the null hypothesis that the mean, rather we do not reject the null hypothesis that the mean is 15 or larger. And if we use the p-value approach, the p-value is 0.6066, which is larger than 0.1. Therefore, we do not reject the null hypothesis. So the interpretation of that decision, then we say that there is not enough evidence to reject the customer's suspicion that on average the software company is not responding in less than 15 minutes at a significance level of 0.1. And an additional commentary to this is that the sample mean of 14.8 minutes is slightly less than 15, but the variation of the observed response time is 5.2 minutes, quite large. So one thing based on what we found, you can propose to the manager that they do not only need to reduce the average time, they need to reduce the variability of the response time as well. All right, so this is example 2. Let's talk about example 3. In this case, a research organization claims that the average lifespan or the replacement cycle time of consumer desktop PCs in the United States in 2020 is 72.6 months. So a recent survey of 35 randomly selected sample computer users resulted in a sample mean of 74.5 months and a standard deviation of 6.15 months. So the question is there enough evidence at a significance level of 0.01 that the Consumer Research Organization claim is correct? All right, again, we're dealing with averages, lifespan, which is time. And so now you know that the lifespan or time is a continuous random variable, and we're talking about the population mean. And the significance level is 0.01. So the first step, summarize the information given in the problem. You see that the mean under the null hypothesis is 72.6 months. We have 35 observations randomly selected. The sample average is 74.5 and the standard deviation is 6.15 and the significance level is 0.01. All right, so in here you notice that this organization says that the average lifespan is 72.6, implying equality. So that's telling you what the null hypothesis is. So then we write the null hypothesis, the mean is equal to 72.6 months. And therefore, of course, the alternative hypothesis is that the mean is not 72.6 months. So that tells you this is a two-tail test and the significance level is 0.01. All right, so now this is a random sample that implies independent observations. The sample size is 35. So based on the central limit theorem, we can say that the sampling distribution of the mean is normal. The population standard deviation is unknown, but we know the sample standard deviation, and we'll use that to replace that sigma. And so we are justified in using the t-distribution with 34 degrees of freedom. Right, next step, we calculate the test statistic, and we use the sample mean, the value of the population mean under the null hypothesis, the sample standard deviation, and the sample size. Again, you carry out this calculation and you obtain 1.8277. All All right, in step 4, and again, I'm going to illustrate both approaches. We're going to look at the critical value approach. All right, on table 5, using now alpha is divided between the two tails because it's a two-tail test. So for a probability of 0.005 and the degrees of freedom of 34, then looking at that row of degrees of freedom of 34 under the column of a probability of 0.005, you find a t-value of 2.728. But that's only the t-critical on the right side. So we also need the critical value on the left side, which is just the negative of this number because of the symmetry of the t-distribution. So the rejection region is going to be to the left of minus 2.78 and to the right of 2.728. Again, if you like to find the critical value, which is, we found the exact value from the table, but here's the formula to find it. All right, if we follow the p-value approach, again, we go on table 5, we look at the row for degrees of freedom of 34, and on that row we find the calculated value of the test statistic, 18.277. Of course, in this case, we don't find that value, but we look at the two values that are just below it and above it, and we find that the value below is 1.691 and the value above it is 2.032. And this corresponds to the probabilities of 0.05 and 0.025. But remember, these are the probabilities on the left side, only on the left side. We need to consider the probability on the left side because the t-value is, or the lower value is the negative or the positive value, so we have the same areas on the left side. So to find the p-value, we multiply this 0.05 and this 0.025 by 2. So then we can say that the p-value is between 0.1 and 0.05. Now, to find the exact p-value using this formula right here, we see that it's 0.0763, right between these two values. All right, so now that we found the critical region, or the rejection region, I should say, and the p-value, then we move on to make a decision. So the critical value, in the critical value approach, we find that the calculated value of the test statistic, 1.8277, is between the critical values of 2.728 and minus 2.728. That means it's in the non-rejection region. So we do not reject the null hypothesis. The same with the p-value approach. We find that the p-value is 0.07638, which is larger than 0.01. Therefore, we do not reject the null hypothesis. So we interpret that decision as at a significance level of 0.01, the consumer research organizations claim that the average lifespan of consumer desktop PCs in the United States in 2020 is 72.6 months, cannot be rejected. So we believe that that is the actual situation. And so I'm saying here as a commentary that even though the sample mean of 78.5 months is higher than the proposed population mean of 72.6 months, the difference between these two values is 5.96 months, almost 6 months, is not large enough to be considered statistically significant because the sample variation is relatively large, more than 6 months, and the sample size is relatively small. So that's why we couldn't say that this difference of almost 6 months was statistically significant. All right, with this part, we finished the section for testing the population mean.